Today, let us see some more sums on root locus techniques. Obtain the root locus for a unity feedback system with the open loop transfer function g of s equal to k upon s multiplied by s square plus 6s plus 25. The open loop poles are p equal to 0, minus 3 plus or minus j4. Zeros, no zeros, z equal to nil. Therefore, n equal to 3 and m equal to 0. So, number of root locus branches equal to 3. And all branches end at infinity. All branch end at infinity. Now we have to find the angle of asymptote at which these root locus branches are going to infinity. That is plus or minus 2q plus 1 multiplied by 180 divided by n minus m, where q equal to 0, 1, 2. N equal to 3, therefore 60 degree, 180 degree and 300 degree. So these are the angle of asymptotes. The root locus branch will end at infinity at an angle 60 degree, 180 degree and 300 degree. These asymptotes will meet at centroid sigma a equal to sum of real parts of poles minus sum of real parts of zeros upon n minus m. That is equal to minus 3, sum of real part of poles minus 0 divided by 3. That is minus 6 by 3 minus 2. They are meeting at minus 2. They are meeting at minus 2. So now let us draw the root locus. Sigma j omega s plane 0, minus 1, minus 2, minus 3, minus 4, j, 2j, 3j, 4j, minus j, minus 2j, minus 3j, minus 4j. The poles, the one pole at origin, the another pole at minus 3, minus 4, and another one is minus 3, minus 4j. These are the poles. So any point, if we select on the negative real axis, it is on the root locus. Therefore, the entire negative real axis becomes part of root locus up to infinity. It is part of root locus. Since it is a complex pole, we have to find the angle of departure. At what angle it comes out. To find that angle of departure, we have to find one pole is at minus 4j, and minus 3. Another pole here. If we join, so we have to find the angle of departure at P3. Join P3 and P2. Join P3 and P1. we have to find this angle theta 1, this angle theta 2. Theta 1 equal to 180 minus tan inverse of this is 4, this is 3, 4 by 3. That is equal to 180 minus 53.13. That is equal to 126.78 or 8. 126.9. 126.9. Theta 1. Theta 2 equal to, obviously it is 90 degree. So therefore, angle of departure at 5P3, angle of departure equal to 180 plus net 5 net. 5 net equal to 180 plus, these two angles are far poles, therefore minus 126.9 minus 90 degree. That is equal to 36.9. 36 point minus 36 minus 36.9. Therefore, the angle of departure is minus 36.9 from here, minus 30, angle of departure 5P3 equal to minus 36.9. Therefore, 5, this is P1, this is P2, and this is P3. 5P2 equal to plus 36.9. So we got the angle of departure that we have to draw. So we have to draw a horizontal line. So we have to draw a line at an angle 36.9 minus 36.9. Similarly, draw a horizontal line. Draw an angle 30 plus 36.9. So it come out at this angle. It come out at this angle. Come out at this angle. Come out at this angle. Here it come out at this angle. Now we have to draw the asymptotes. 3 asymptotes, they are meeting at minus 2. Minus 2. One is at 60 degree. 60 degree. One is at 60 degree. One asymptote is at 60 degree. Another one is at minus 60 degree. That is 300 degree. The third one is 180. That is 1 over. It is above that root locus. That's all. These two are asymptotes. This is also asymptote. Now it come out, and where it intersects the j omega axis we have to find. Then we can draw the root locus. Already one branch is over. It starts at 0, end at minus infinity. These two branches coming out at minus 36, and this is coming out at plus 36.9. And where it intersects the j omega axis, that we have to find. For that, we have to form the Root array. Root array we have to form. For that, this 1 plus g of s is k upon s multiplied by s square plus 6s plus 25 equal to 0. This implies s cube plus 6s square plus 25s plus k equal to 0. Therefore, the Root array is s cube s square 1625k. S power 1 equal to 150 minus k divided by 6. S power 0 is k. Now, s power 1 rho has to be made equal to 0 to find k max. Therefore, k max equal to 150. Substitute in this, we will get 6s square plus 150 equal to 0, or s square equal to 25, s equal to plus or minus j5, or j omega equal to plus or minus j5. Therefore, omega equal to j omega equal to j5. So they are meeting here. They are meeting here. j5 here. They are meeting at minus j5. Therefore, now we can draw the root locus that goes this way, and this also goes infinity this way. So it goes up to infinity. That's all. Now, suppose we want to find find the value of k, so that zeta equal to 0.7. 0.7. How to find? What is the root locus? The root locus, if you draw on a graph sheet, it will be looking like this. It will be looking like this. There is no breakaway points. If you find dk by ds, if you find dk by ds, if you find dk by ds, you will get the roots are minus 2 plus or minus j 0.5 root 39. They are not on the root locus. They are not on the root locus. It is obvious. No need to find that. But if you find it will give the roots which is not on the root locus. So this is the root locus. This is 36.9 degree. Zeta equal to 0.6. For that, we have to find the value of k. Therefore, cos inverse of 0.6 equal to 53.1 degree. So we have to draw an angle, a line at an angle 53.1 degree. So the angle here is 53.1 degree. This is zeta equal to 0.6. Constant zeta line. So now it intersects at A. So we have to find the value of k at A. For that, we have to join all poles to that A. So we have to join like this. Here also you have to join, and here also you have to join with these poles. Now let us, what is that point? The point is 2, minus 2 plus j 3.5. That is A equal to this. Now we have to find the distances. This is P1, this is P1, this is P2, this is P3. Now we have to find the modulus of AP1, modulus of AP2, and the modulus of AP3 we have to find k at A. So AP1 equal to modulus of minus 2 plus j 3.5. P3 is minus 3 plus j4. Minus of minus 3 plus j4. That is equal to minus 2 plus 3 is 1. 3.5 minus 3 plus 3.5 minus 4. So minus 0.5. Minus 0.5. Minus 0.5. J 0.5. So for this, we have to find the distance. So we have to call the function polar modulus of AP1 equal to, call the function polar 1 comma minus 0.5. Like that you can find, or you can find square root of 1 square plus 0.5 square. That way also you can find AP1. Similarly, AP2 equal to what? Minus 2 plus J 3.5 minus of, the next pole is 0. That's why you will get the same point, modulus of minus 2 plus J 3.5. To find modulus of AP2, what we have to do? Call the function polar minus 2 comma 3.5, or you can find the square root of 2 square plus 3.5 square. That way you can find AP3 equal to polar minus 2 plus J 3.5. That is the point A, minus the coordinate is minus 3 minus J4. That is equal to modulus of minus 2 plus 3, therefore 1, and plus 3.5. This is plus 4, therefore 7.5, plus J 7.5. So we have to call the function polar 1 comma 7.5, or you can find the square root of 1 square plus 7.5 square. So we got all the lengths. Therefore, K equal to, K at A equal to AP1 multiplied by AP2 multiplied by AP3 whole 1. There is no zeros, that's why denominator is 1. This way we can find the value of K, so that the closed loop poles will be at A, so that the damping factor is 0.6.